Hello, today I would like to present the architecture of Tracardi and differences between version 1 and version 2. Version 2 is not available right now. It should be available around second quarter of this year. But this presentation will show you what's the main difference between the two versions and what is the architecture of the system. So with the version 1.x, we have this stack of the dependencies. So beneath we have operating system, then we usually install Kubernetes, and then we have Elasticsearch plus MySQL. Elasticsearch keeps the big data and MySQL keeps the metadata of the system. And then we have in parallel running Apache Pulsar, which is a queue, and Redis. And on top of this, we have workers that use Apache Pulsar to distribute the load, and they also use Redis to access MySQL, so we don't stress MySQL very frequently. And then on top of this, actually we have Tracardi API, which is a collector, and we have Tracardi graphical user interface that uses this API to access the system. And in the new version, we will have a bit different architecture. We also will have operating system and Kubernetes, and we will use data warehouse for the big data, not Elasticsearch. And we also use Apache Pulsar for a queue, and Redis for caching. And on top of this, we have workers. So workers use Apache Pulsar to get the data and push it to the warehouse. And on top of this, we have a collector API, which is a separate API for collecting data. In version 1, we had collector integrated into the Tracardi API. In version 2, we'll have a separate Tracardi GUI API that will use only MySQL just to store the metadata. And now I would like to explain how the collector works, because this is quite important to understand how we use the dependencies. We'll start with a version 1.0, that is an open source version. Open source version differs from the commercial version. It's quite important to understand what are the differences. So in here we have like one server and one thread, and we have an API. Okay, through the API we collect data, so it's the responsibility of the HTTP server, and within that one execution we have everything. So we have an API that collects data, then there's a workflow, and there's the destination where we send the data. We process the data in a sequence. So when there's an event, API collects it, it goes through the workflow and goes to the destination. If the destination is configured, it just goes to that destination. And of course, somewhere in the middle, we store the data. How quickly it runs, it all depends how long is this process. And during this process, we access Redis and MySQL to read the metadata, so how the data should be processed, if it should be validated or reshaped or sent to some destination. We use Elasticsearch to store the data, and then when you use a workflow, we also use Elasticsearch and CPU to process it. And destination also use CPUs on Redis and Elasticsearch. I've made this light blue blocks just to show you how long the user will wait for the data to be collected. So it's quite long. Now we have an architecture of a commercial collector, also from the version 1.x. So now we have the load spread among servers. First of all, we have HTTP server with the API, and this API usually responds within 15 to 20 milliseconds, and it just gets the data. It uses MySQL and Redis to find out what it should do with this data, and then it pushes it to the Pulsar, to the queue. Then on the different server, on a different thread actually, there is a background worker. This is a general purpose worker that will process the data. It will store it into Elasticsearch. It all depends, because the worker can do different things, but most of the time probably it will store the data to Elasticsearch. But this is separate from this thread, from this process, so user waits a bit, actually a lot of time less. And then the background worker can also span, make another workers to work. So it also uses Apache Pulsar to just, if it decides that it should store it in a separate storage worker, then it uses storage worker. It uses destination worker to send the data, workflow worker to process the data within the workflow. So there can be different workers. And they can run on a separate server. This is quite different architecture, and it's much more performant. And now for the version 2.x, which, as I said, is not available right now, but should be available within 3 to 5 months. And now we have everything actually decoupled. We have one process that just collects the data. Here we go. We have a API that can process, one thread can process about 250 requests per second. That is about 4 milliseconds. So it very quickly gets the data and pushes it to the pulsar, and then there is a worker that stores it, and that worker processes it. Around one worker can process about 5,000 requests per second, and it's stored in the warehouse. And then there's a separate process. It's not in a sequence like in the previous version. We had the sequence, so there is one server, and then the sequence went to the background worker. Background worker could not start working without the API sending it the data. But right now, the build worker is totally separate. It just runs from time to time and just gets the data from the warehouse and process it every minute, every 15 minutes. It depends on the configuration. There's a build worker that builds the data. So this part collects events, and this one builds the customer profile and other entities. And it also can, start a destination worker or a workflow worker, but they are all separate. It uses Pulsar, CPU for processing, and data warehouse plus MySQL to store the data. Actually, MySQL is only read, just the definition how the data should be processed. This is like a general overview of the architecture. One very important thing is that the difference between version 2.0 and 1.0 is that when we look at this stack in a version 1.x, everything actually is coupled, because we cannot replace Elasticsearch with other storage. In the version 2.x, everything is written using adapters. So right now we are using some data warehouse that will be a Starlog database. But in the future, we'll be able to replace this data warehouse with any other data warehouse. The same MySQL could be replaced, Redis and Pulsar. For example, Pulsar could be replaced with Kafka. Everything in here is based on adapters. And this is basically it. This is how Tracardi works. What is the architecture of the data and how the data flows. If you have any questions, please post it in the comments and we will reply to them. Thanks.